Printed circuit board routing practices. After auto-routing in electronic design, PCB routing is the positioning of conductive pathways on a printed circuit board before final soldering and interconnection. The purpose of PCB routing is to have an arrangement where signal traces connect electrically to components and other signal traces while avoiding the signal crosstalk and maintaining short electrical paths between the components. You can have a manual PCB through computer-aided design software or the use of specialized routing hardware, such as manually controlled routers or auto-routers. How to reset your board after auto-routing. If you've used an auto-router, but you're not happy with its results, you can fix it in different ways. Moreover, if you know what a DRC is, you can use it to override certain errors that auto-router made. DRC means the design rule check, which you can perform by running an IC or error report check. The IC will report all of your errors on your design file on a text file. It will then tell you how many errors are found in each layer. You can then go into each layer and manually change any error that was reported by using the pcad's drag function to move components around until they fit perfectly within their pads or tracks. This is also known as drag fitting. When everything fits perfectly, save your design as a new version so that you don't accidentally erase anything important. Once saved, run another DRC and see if it finds anything else wrong with your board layout. If not, continue with another step to check for shorts between traces/pads/vias/traces, etc. After fixing these issues, perform another DRC again. Now that everything looks good, export your Gerber files. Make sure you select the top copper layer only and then hit OK. Your Gerber files should now be ready to send off for PC board fabrication. How to manage multiple copies of the same net in printed circuit boards. Nets are electrical connections between different parts of a design. For example, if you have an LED that is connected to the ground and another net that connects to a microcontroller through various resistors, there will be two nets connecting these two components. You need to route one copy of each net in your board file in order for it to be used in your design. Having too many copies can make it difficult to update or change an element of your circuit board design. In case you have several copies of a net, they will all be shown in different colors. But, you should always try to join them together instead of having multiple copies. The PCB editor provides a Merge Nets option which can do that for you. To use it, just click on it in one of your nets and select another net for merging. You can do that with as many nets as needed. When finished, press OK and then save board to save your changes. You can easily learn it through various video tutorials available on the internet. How to manage tight spaces in PC board routing. The key to successfully routing a PCB with tight spaces is in visualizing what you're doing. If you can see it, you can do it. Once you have a clear picture of your goal, there are several techniques to deal with PCB obstacles that make it possible to route those hard-to-reach traces. Here are some tips on managing tight spaces. Place your components as close together as possible. This will leave plenty of room for routing at either end of each component lead. Put components with shorter leads toward one side. This allows more space for routing on other sides, where longer leads might overlap. Use right angle headers instead of straight headers when possible. They're easier to route around obstacles because they have a narrower footprint. If you can't use the right angle headers, place them closer to an edge than a corner. Use large pad ICs instead of small pad ones when possible. Large pads make it easier to route around them without accidentally overlapping their neighbors. Put components with longer leads toward one side. This allows more space for routing on other sides, where shorter leads might overlap. Place through-hole components near an edge. This leaves plenty of room for routing on other sides, where smaller holes might overlap. It also makes it easier to access component pins from both sides. Route clockwise around obstacles when possible. Clockwise routing tends to be smoother than the counterclockwise routing because it keeps your drill bit moving forward rather than backward. Tips on hard-to-route pins, vias, signals, planes, and more. One of the biggest advantages of auto-routing tools is that they save you a ton of time by automatically planning out your board's signal paths. Though these tools are very convenient to use, there are certain types of signal paths that can be very difficult for them to handle. Here's a quick rundown on some common hard-to-route signal paths and what to do about them, so you can make sure your PCB design doesn't have any issues during production. Multi-layer boards allow you to create more complex circuit layouts than would otherwise be possible with a single-layer PCB. But, when it comes down to it, most manufacturers prefer single-layer boards because they don't cost much more and will typically get you faster turnaround times than multi-layer boards. If you're trying to decide between single-layer and multi-layer, here are a few things to keep in mind. Multi-layer boards require additional fabrication steps. Though multi-layer boards do indeed allow for more routing options than their single-layer counterparts, they also require additional fabrication steps which increase the manufacturing costs. This means that unless you need those extra layers, it's probably best to stick with a single-layer board. The single-layer printed circuit boards can fit more components. This may seem like an obvious point, but when designing your layout, remember that multi-layer boards have smaller component pads and traces than their single-layer counterparts. Each layer adds another set of traces and pads. So, if you're looking to fit more components onto your board, you should consider sticking with a single-layer PCB. In other words, both multi-layer and single-layer PCBs have their pros and cons. So, if you aren't sure whether or not you should use one over another, or if you simply want to play it safe, go ahead and choose a single-layer board instead. Avoid over-relying on auto-routing. Though auto-routing is a great help, you cannot over-rely on it. Besides, you have to select the right software for this purpose. There are lots of free software available on the internet which might or might not work well in this case, so choose carefully. You should have practice to route traces with any software that we will discuss further. Besides, there are different parameters of auto-routing that should be precise. However, they vary from project to project or between different modules on a single printed circuit board. Top 5 tips for manually routing a circuit board. There are different things to consider while manual routing on PCB, such as, 1. Keep your route sizes as consistent as possible. Having a fixed grid is highly beneficial when it comes to routing. You should lay out your design in a way that allows you to connect pin to pin with no more than 5% variation from expected routes. It ensures an optimal layout before starting any manual routing work. 2. Use proper start and endpoint selection. Starting a route at a pad or component lead not only wastes time but also affects a board's signal integrity. To avoid these issues, always use endpoints or pins for start/endpoints whenever possible. 3. Avoid using vias for signal layers. Vias are used for connecting two different copper layers on a PCB, not for connecting two pads on one layer. If you need to connect two pins on one layer, consider using microvias instead of traditional vias. 4. Don't overlap traces. Overlapping traces can cause different kinds of problems, such as ground loops and impedance mismatches. So, make sure you leave enough room between each trace for easy soldering and troubleshooting later on. 5. Focus on long-term flexibility. Once you have routed your board, think about how you might want to change it down the road. For example, will you ever want to add another connector? How about changing around some components? You may find that adding the solder mask artwork into your design software now will prevent you from lots of headaches later on. Your ability to change the designs without having to reroute everything from scratch makes a huge difference in future productivity and costs. The best way to learn new skills is by doing new things, so don't be afraid to take chances and be innovative. You can develop the best PCB by focusing on different techniques and design parameters, for which you can also read our other posts. Would like to know more about PCB routing practices after auto-routing or PC board assembly? Email us at sales@pnconline.com.